In this video, we're looking at factoring polynomials. So the first thing we should always do when trying to factor a polynomial, like the problem here in example A, is to factor out a greatest common factor. But I don't think there's anything in common between these two terms, correct? I mean, x squared doesn't have any numbers and 49 only has numbers, so I don't think we're going to find anything common there between those two. Now, since we don't have anything in common between them, then the next thing we need to consider is, of course, the number of terms that the polynomial has. In this case, this polynomial has 2 terms, so that means we should be looking for special products, right? And example A has a very classic special product. This is the difference, right, because it has a subtraction sign, of 2 items that are squared. So x squared is literally x, the variable, squared, and 49 is the number 7 squared. So we have a difference of squares here. So we're going to apply the difference of squares factoring technique. So for the difference of squares factoring technique, we're going to draw 2 parentheses side by side. We're going to take the root of the first term and place it in the first position in each of those parentheses. And then we're going to take the root of the second term and put it in the second position in both parentheses. And then all we have to do is put a sign of each in each parenthesis. So plus and minus is how we split up the 2 different signs. And again, if you were to multiply this back out, you can confirm that it does multiply to give you x squared minus 49. And we've done what we're supposed to do, which is to express the polynomial as a product, in this case, a product of x plus 7 times x minus 7. So that's it. Okay, looking at our second example, again, we would look for the greatest common factor, but you can see here that this last term is really simple here. It just has a 1, and of course, we could always factor out a 1, but that doesn't really do anything in this case. So we're going to say that there is no GCF. All right, from there, we're going to consider the fact that it's a 2-term polynomial, and that means that we're going to be looking for a special product of some sort. And in this case, I can see again that this looks like something squared, and this is something squared. So in other words, 36 is 6 squared, 1 is 1 squared, and x squared is, of course, x squared. So that means it is a difference of squares because we have a difference in the middle and we have 2 items or 2 terms that are both squares. So we'll draw 2 parentheses like we did last time. We'll take the root of 36, which of course is just 6, and we'll place that in the front of each parenthesis. And we'll take the root of x squared, which of course is just x. We'll place that also in the front in each parenthesis. And then we take the constant back here, 1, and the root of 1 is of course 1, so we'll take that and put it in the back of each parenthesis. And then we know we put a sign of each, so we'll have plus and minus. So in each parenthesis we have a 6x and a 1, and then we have the 2 different signs split between the parentheses. Okay. All right, so example C is asking us to factor the polynomial again. Now, the first step is always to look for the greatest common factor, something that would go into both terms in this case since we have a binomial. Well, I think 32 and 18 have something in common, right? I can tell you for sure that 32 is divisible by 2, and I know that 18 is divisible by 2, so we should try pulling a 2 out of both of those. If I divide 32 by 2, what do I end up with? Well, 32 divided by 2 is, of course, 16. That'll leave 16x squared. Then the minus sign, and if I put 2 into 18, 2 divides into 18 evenly 9 times. All right, so we have 2 times 16x squared minus 9. Now we need to consider if we can factor the leftover binomial here. Well, I think we can, because whenever you have a binomial, you have to consider if we're dealing with a special product. In this case, it's clear that we are, because 16 is something squared, it's 4 squared, right? And x squared is something squared, it's x squared. And then 9, of course, is something squared, that's 3 squared. And we have a different sign in the middle. So it looks like we're dealing with the difference of 2 squares again. All right, so let's bring down our greatest common factor. Always make sure you bring that greatest common factor down in your very first step. Then draw your 2 parentheses side by side. And remember, 16 will break up into 4 and 4 because the root of 16 is 4. The x squared will split up as x and x into each parenthesis. The 9 gets broken up as 3 and 3, and that'll be in the back parenthesis because the square root of 9 is 3, remember? And then we put a plus sign and a minus sign in the 2 parentheses. All right, and that's our solution then. All right, let's finish our last example here, the 20x to the 4th minus 5. So this polynomial also has a greatest common factor. Remember to check for the greatest common factor before you do anything else. So we're going to factor out a 5 here to start. Now when I factor out a 5, 20 divided by 5 gives us an answer of 4. Then we're left with x to the 4th minus 1 because 5 goes into itself one time. Okay, so now that we've pulled out our 5 as our greatest common factor, let's try to factor the remaining binomial. All right, so let's bring down our 5, our GCF, and then let's create two parentheses and try to split up this binomial as a difference of two squares. The reason why I think it's a difference of two squares is because clearly it's a difference, and 1 is something squared, and 4 is something squared, and lastly, x to the 4th is x squared squared. So it looks like we're dealing with the difference of two squares again, so a special product. Okay, so the 4 will be broken up into 2 and 2, right? Because the square root of 4 is 2. The square root of x to the 4th is x squared and x squared. And the square root of 1 is 1. So we'll put 1 in each of the parentheses in the back end of the parenthesis. And then, of course, we put the plus and minus sign in. Now, at this point, we still want to check to see if we can factor any further. But looking at this binomial, I can see that there's nothing in common between the two terms, and it's not a difference of two squares. Now, looking at this second parenthesis, you may think it's the difference of two squares at first, but of course the 2 here in the front is not a square. So the 2 here is not going to allow us to factor this as a difference of two squares. If the 2 wasn't there, we could split it up as x minus 1, x plus 1, but the 2 prevents that from happening. 2 is not a perfect square. We can't factor it out as a greatest common factor. So basically, we're done.